Hi there, I'm Simon St. Laurent, Senior Editor at O'Reilly Media Inc. and soon to be co-chair of OSCON 2014. I'm here talking about OSCON 2013. Right now I'm here with Augie Fackler and Nathaniel Manista from Google, and they have this amazing anti-Rumsfeldian approach to software. I'd like to sort of start with where you came from, the world of objects and the tools you were using. What triggered this change?
What triggered it was pain with orthodox object orientation tools and philosophies and designs, and frustration with the promise of object orientation simply not coming to pass, and finding better ways, finding superior techniques, things that produced behaviorally equivalent code, but code that was more maintainable, code that was more robust against mistakes of our own implementation.
Or more robust, because at Google, teams tend to turn over somewhat rapidly, right? You're on a project for 2 or 3 years, and then it's common to move on. I haven't, but Nathaniel has. And having it be robust against handing it off and not having to spend 6 months saying, now this is how we laid out all the code. Making it very self-documenting became very important.
Right. I was talking earlier about functional programming, and it's the human factors involved. You can hand off a function and it's more comprehensible, usually. What kind of patterns did you come to as you were looking for alternatives? Describe the architecture.
So we came to a mix of patterns. We came first to composition. We got a fascinating question after the lecture today about what about mix-ins, right? Are mix-ins a way to redeem inheritance? And it turns out that they're not. They have about half of the advantages of just flat-out composition, so you should just use flat-out composition.
And mix-ins also end up being very frustrating very quickly when you start trying to figure out, say, 2 mix-ins overlap a little bit, what happens?
Right.
Yeah. And so then we were working in a Python environment, so we came to think of our modules as larger than just classes. And this is something that's not very traditional in the Java side and a few other different areas. But when you start to think about your modules as not necessarily the same as classes, but collections of functions and maybe some classes and a grab bag of these things,
right.
And then we started to apply these techniques, we noticed the classes started disappearing. They started getting smaller and smaller and smaller and then disappearing. And we found ourselves talking about our modules in terms of functions and types. And that was very natural, that was very comfortable, and it produced fantastic software. And we just had to tell the world.
Right. Over what kind of time? How did this, it sounds like it evolved. It doesn't sound like you sought out to destroy classes. You just kind of got there.
No, it was really around the time that I started, we ended up doing a major refactor across the entire product that we were working on. And it got really, really frustrating in Python, partially because the compiler isn't doing any type checking, so you could change a function signature and then you'd find out at runtime it was broken. But beyond that, it was frustrating because there were weird undeclared circular dependencies that we hadn't noticed before. And so over a period of probably 2 years, we first kind of lived with it and tried to test our way out of the problem. And eventually, one day Nathaniel introduced a new abstraction layer that teased apart some things and broke a circular dependency, and suddenly it all made sense. And it was for me, it was an aha moment when I was doing the code review that was just, oh, we should be doing this all the time.
And so to give you some concrete numbers, this was a code base that was about 7 years in total old, and about 55 developer years worth of work. So a large
mostly
code
Python
base.
too.
So mostly Python and a large code base.
Wow. And you came to anti-Rumsfeldianism? Can you tell us a little?
There's been part of the object orientation orthodoxy that I picked up in my training and my early career had been that if you just pick the right objects, if you just design the right objects, then everything will fall naturally together. Everything will interplay together in a natural way. You won't even have to think about it very much. And what we find is that that's just not true. You can have very interesting behaviors, very valuable behaviors that are separate, right? And they're each sort of off in their own domain or magisterium. And you may want to build an application or a larger solution out of these things that don't naturally fit together. And so the question is, well, should you massage them to try and tweak them, to try and coerce them to fit together?
Work with the army you have.
Right, and work with this idea of working with the objects you have and making them fit together? Or should you leave them expressed in terms of the inputs and outputs and the domain boundaries that they naturally form themselves, the ones that they wish they had, rather than the ones that they actually have? And then simply write translation layers between them. And it's the idea that you should write those translation layers.
Because the translation layer makes the higher level code easier to understand, right?
Okay.
And at Google, we do a lot of code review, and so one of the virtues ends up being, can I send this code review to somebody else on the team? And with no further explanation, is everything clear in terms of the intent and the maintainability and the structure? That's the goal we started shooting for.
Code that facilitates communication among the people.
Right, the code is the communication.
Right.
Is the goal.
Right. And you're still in Python. Mostly,
It's actually kind of funny.
Yeah.
Okay.
So I think Nathaniel is basically done with Python as a language.
Yeah. I am on my last Python assignment right now.
Okay.
I've moved on from the project on which we work together.
Okay.
But I've actually picked up a project on which he used to work.
Yeah. Good.
It's also in Python. It's also a web application, so a lot of the same principles apply both to the work that we've been doing before and to all web applications, which is, it's great to have that generality at one's fingertips. It is in Python, and I've just finally run out of patience with all the problems that Python brings.
And so
it's my
Is it the orthodoxy
whatever's next.
pieces,
I don't know what's next.
You don't know what's next. Okay.
But I'm on my last Python assignment now. This came up in a conversation the other day, and I was defending Java, as I do, in a way that surprises him. And I said that I've now gotten to the point with my Java where I see through the problems in the static expression of it. I see through the hundreds of unnecessary tokens on the page, and I see through that stuff to the elegant execution, the elegant runtime, the clean, efficient, sensible runtime. I do the opposite with Python. I now see through the brevity and succinctness and clarity of the text on the page, and I see directly through to the problems at runtime.
Okay.
And I just get so frustrated now. I've lost my patience.
Well, we're working with some pretty tricky pieces, it sounds like. I understand that running out of patience.
And so for me, Python is still something I spend a lot of time in. My open source project that is my 20% time at Google is Mercurial, which is written in Python.
Right.
So there's a lot of Python work still to be done for me. But when I'm writing new programs, I'm finding I'm spending most of my time in Go. And it's actually funny because all of the principles that we outline in the talk are just natural idioms in Go. You don't even think about it. You just write it that way. It falls out onto the page. And so I'm trying to convince him to try Go at some point.
I don't want to make a new friend and put in all that investment of learning a new language for something that has nil in it. I'm done with nil.
Okay.
Yeah.
Good.
So,
well, kind of the last thing is, this seems like something that goes way beyond Python in particular. I mean, object-oriented orthodoxy is kind of everywhere.
right.
So, in an OSCON context, there are lots of polyglot programmers walking around. There are people who are looking for new directions to go. Kind of what would you advise people who are, trying to figure out the best next path? What does anti-Rumsfeldianism look like as you're, setting up a new project, for instance, instead of refactoring?
So what I've thought about it in terms of that is, we have this long, proud, healthy, fantastically productive open source ecosystem that makes so many different tools so immediately available that's really great. It means that when you're adding to it, you can often express your new thing in terms of the tools you happen to be using, right? And they're readily at hand, and it seems sensible to say, like, oh, well, because I use this particular search mechanism or this particular storage mechanism or something like that, I'll just write my code in terms of those, because they're open source too.
Right.
They can be counted upon to be everywhere, and that's great. And that actually runs into problems at large scale. And basically, we're doing everything at large scale these days. Yeah. So some anti-Rumsfeldianism could help there. A moment's reflection or more.
Right.
You know, it's more of a design pressure than a magic bullet, clearly.
Right.
But something to say, I'm going to write my new thing, and I'm going to write the types, and I'm going to write the interfaces upon which the new thing needs to run. And then those interfaces happen to be implemented by these existing tools that people have today. But they might be implemented by other things that come along later, or things that have already died and are being resurrected, or things that happen to be differently available under different licenses or different circumstances. And I'd love to see a lot more points of articulation in the open source ecosystem that this little bit of extra abstraction would afford, but would allow so much more interplay, rather than you go to download one package because a friend recommends it and it needs exactly this other implementation underlying it, exactly the second implementation underlying a different dependency or something like that, and this rigid lock.
So loosening those bonds.
Yeah, I would love to see that.
Right. A part of me dies inside when I think of some of the new Linux system management tools, which end up using things in ProcFS or something, and they're completely unportable as a result, right? In some of these cases, there's not a reason for it. I'm sure there is in some of them, but I run FreeBSD servers at home, so that's why that frustrates me. That's a particular example that comes to mind. It feels like it's avoidable.
You want more flexibility.
Yeah.
Beautiful. Okay, well, thank you very much, guys. I wish you luck in your
thank you for having us.
and finding new languages, and this should be great. Thank you.
Wonderful.